Welcome back to 30 Days of Physics with Miss B, and we're moving right along into kinematics. Kinematics is a branch of mechanics concerned with the motion of objects without reference to the forces which cause the motion. The quantities used in kinematics are distance with SI units of meters, time with SI units of seconds, velocity with SI units of meters per second, acceleration with SI units of meters per second squared, and speed with SI units of meters per second. Speed is a scalar quantity, which means it only has size or magnitude. It is the rate of change of distance. It is determined by how much distance is traveled in the time taken to do so. Speed is equal to distance over time. Information about the speed of a moving body in the time taken to do so can be produced graphically by a graph of distance against time. The gradient of the graph will give you the quantity of speed, meters per second. Velocity is a vector quantity. It has both size and direction. It is the rate of change of distance in a specified direction. It is determined by the amount of distance traveled in a stated direction, which is referred to as displacement in the time taken to do so. Velocity is equal to displacement over time. Information about the velocity of a moving body can be produced graphically via a graph of displacement against time. The gradient will produce the quantity of velocity. What does the shape of the displacement time graphs mean? Graph A represents zero displacement. Graph B represents constant velocity. Graph C represents a decrease in velocity, and graph D represents increase in distance, which eventually decreases over time. Acceleration is also a vector quantity because it has both size and direction. It is the rate of change of velocity. It is determined by the rate of change of velocity in the time taken. Acceleration is equal to velocity over time. Information about the acceleration of a moving body in the time taken to do so can be produced graphically via a velocity time graph, where the gradient produces the quantity of acceleration. The distance traveled by the object can be determined by finding the area under the graph using the formula for the area of whatever shape is formed, which is a triangle in this case. If another shape such as a rectangle were there, then the formula of length times width would be used. What does the shape of the velocity time graphs mean? Graph A represents zero acceleration. Graph B represents constant acceleration. Graph C represents constant deceleration. Graph D represents increase in velocity, which eventually decreases. There are 4 equations of motion that may be used to solve worded problems without the use of graphs, where S is equal to distance in meters, V is equal to final velocity in meters per second, U is equal to initial velocity in meters per second, A is equal to acceleration in meters per second squared, and T is equal to time in seconds. The 4 equations are V is equal to U plus AT, V squared is equal to U squared plus 2AS, S is equal to UT plus a half AT squared, and S is equal to the sum of U and V times T all over 2. Let's try to answer a question by determining which of the 4 equations is suitable for use. A ball falls from rest with a velocity of 20 meters per second. How much time does it take the ball to fall? First, list all of the variables that were given. Initial velocity is 0 because it is falling from rest. Final velocity is 20 meters per second because it's falling. Acceleration would be, due to gravity, 10 meters per second squared, and what we're looking for is time. All of the variables listed tells us that we're going to use number 1, v is equal to u plus at. With a little bit of transposition, we have t is equal to v minus u all over a. 20 minus 0 divided by 10 will give us 2 seconds. Here's another question. Using the graph below, determine the distance traveled by the object. Tip: look at the shapes under the graph line and the x-axis. Answer: we have two triangles, A and C. Using the formula for the area of a triangle, half base times height, we get A to be equal to 100 meters and C to be equal to 150 meters. Note well that to find time, you must minus 60 from 75 to account for the time between there only. The next shape is a rectangle, B. So we use the formula to determine the area of that shape, length times width. So we get B will be equal to 1000 meters. Note well, we accounted for the time between 60 and 10 seconds, which we get as 50 seconds. Then, with all that done, we simply add all of the distances that we would have calculated. And from there, we will get the total distance traveled, which ends up being 1,250 meters. Alright guys, I want to thank you for watching this episode of 30 Days of Physics. Keep up with me. See you tomorrow for day 9. Bye!